Hello, everyone, and welcome back. I know, exams are just around the corner. And there's one chapter that's probably giving you a little bit of tension, right? Integrals. But listen, don't you worry at all. What if I told you that this chapter is actually easy? Yes, it is. You just need to look at it in the right way. So, take a nice deep breath. We are going to break it down together, and I promise, by the end of this, you'll feel so much better. So let's make this simple. Okay, so first things first. Before we even look at a single formula, we need to understand the big secret of integration. What is it really?
Here it is. Integration is just the reverse of differentiation. That's it. That's the secret. You know how in differentiation we take a function and find its derivative? Well, with integration, we're given the derivative, and our job is to find the original function. It's like working backwards. That's why the answer is also called an antiderivative. We are literally undoing differentiation. Simple, isn't it?
Just look at this. It makes it so clear. Differentiation takes you from f of x to f prime of x. Integration is just the return journey. It takes you right back from f prime of x to the original f of x. It's a perfect two-way street.
Now, since we're going backwards, we have to be careful. And on this journey, we meet a very, very important little character. I like to call him our mystery guest, the constant c. Let me ask you a quick question. You all know the derivative of sine x is cos x, right? Good. Now, what's the derivative of sine x plus, let's say, 5? Or what about sine x plus 500? Just think for a second. The answer? It's still just cos x. Why? Well, because the derivative of any constant number, whether it's 5 or 5 lakh, is always 0. So when we differentiate, that constant part just poof, it vanishes, it's gone. And that creates a small problem for us. When we integrate, when we go backwards from cosine, how do we know if the original function had a plus 5, or a negative 10, or nothing at all? We don't. That information was lost. So to be safe, we just add a plus c at the end of every answer. This c is our way of saying, hey, there could have been any constant number here. It's our little placeholder for the mystery guest. Please, please, never forget to add it. Okay, now that we have the main idea down, it's time to get our tools. Think of these formula as your exam toolbox. They are like magic spells that will help you solve any problem. First up, the most famous one, the power rule. Remember in differentiation you'd bring the power down and subtract 1? Well, here we do the exact opposite. We add 1 to the power and then we divide by that new power. And of course, we add our best friend plus c.
Next up, the trig rules. These are super easy because you already know them. Just think backwards. What function gives you cos of x when you differentiate it? Exactly, sine of x. So the integral of cos of x is simply sine of x plus c.
And for the integral of sine x, just be a little careful. The answer is minus cos of x plus c. Why the minus? Because remember, the derivative of cos of x is negative sine x. So to get back to a positive sine x, we need that negative sign in our answer. This is a very common place to make a mistake, so just keep an eye on it.
All right, that's enough theory. You know the best way to learn math is to actually do math. So let's take a simple problem, just like one from your textbook, and put our new tools into action.
Here we go. Find the integral of sine x plus cos x. Now don't let the bracket scare you. This is actually a very friendly question.
So the first thing we can do is just split this into two separate easy problems, the integral of sine x plus the integral of cos x. And we just learned the formula for these, right? The integral of sine x is negative cos x, and the integral of cos x is sine x. Now technically, each one has its own constant, a c1 and a c2. But an unknown number plus another unknown number is just a new unknown number. So we just combine them into a single, simple plus c.
And just like that, we're done. The final answer is sine x minus cos x plus c. See? How simple was that? You just solved your first integral. You're already getting it.
Okay, but what about the problems that look a bit more complicated? For those, we have a secret weapon. It's a superpower, and it's called integration by substitution.
So what does the superpower do? It lets us take a messy, scary-looking problem and turn it into one of the simple ones we already know how to solve. We do this by swapping out the most complicated part of the question with a simple new letter, usually t.
And listen, this isn't some random trick I'm teaching you. This is a very important method, and it's right here in your NCERT textbook. You can see they use this exact same superpower to solve problems. So if the book uses it, you know it's important. Let's try one.
Okay, team, superpower time. Look at this problem. The integral of 2x times sine of x squared plus 1. Whoa, that looks a bit tricky, doesn't it? But look very, very closely. Can you spot a function and its derivative hiding in there together?
The complicated part is that x squared plus 1 inside the cent, right? So step 1, let's call that t. So t equals x squared plus 1. Now for step 2, let's differentiate t with respect to x. What do we get? We get 2x. Now look back at the question. We have a 2x dx sitting right there. That is the magic moment. So for step 3, we can replace that entire 2x dx with just dt. And suddenly, our scary integral has transformed into the super simple integral of sine of t dt. We know the answer to that. It's just negative cos of t plus c. And for the final step, we just put our original value of t back in. The answer is negative cos of x squared plus 1 plus c. See, the superpower worked.
Wow, we have covered so much and you've all been fantastic. Now for the most important part, the final recap. Get your phones out, everyone. You should definitely take a screenshot of this slide.
So let's quickly review. What is integration? It's differentiation in reverse. And what must you always remember? To add plus c. For the power rule, add 1 to the power and divide by the new power. For the trig rules, integral of cos is sine, and integral of sine is minus cos. And for the tricky questions, look for a function and its derivative, and use your substitution superpower.
And that's it, Beta. You have the basics, you have the main tools. The only thing left to do now is practice. Go through your textbook, try the examples, solve the exercises. You are all so smart, so brilliant, and I have no doubt that you are going to do great in your exams. All the very best.